Hello, Algebra 1 students. This is section 6 of chapter 2, where we're going to talk about ratios and proportions. This should be review from last year, but let's just make sure we know. A ratio is a comparison of two numbers. And we are doing that comparison by division. So a ratio is basically a fraction, where we compare 2 to 3, the comparison of two numbers by division. The ratio of x to y, we would write that as x to y. Alright, sometimes we write it as x to y with the colon. That's also indicating a comparison or a ratio. Alright, we need to express ratios in the simplest form. This implies that there is more than one way to write any given ratio. Alright, so we can write it in many ways, like for example, at the top of the page I wrote 2 to 3. 2 to 3 is the same thing as 4 to 6. It's the same thing as 10 to 15. All of these things equal 2 to 3. 10 to 15 is the ratio of 2 to 3. But when we are writing the final answer, we always put it in simplest form. When two ratios are equal, but given in different forms, we can write an equation that states that they are a proportion. So what I have done here, these are in proportion. 2 is to 3 as 4 is to 6. So that is a proportion when two ratios are equal. Let's determine if the ratio 7 to 8, we can rewrite that 7 to 8, and 49 to 56, are, if they are in a, determine whether this and this form a proportion. Okay, are they a proportion? What number goes into 49 and 56 to make 7/8? 7. If you couldn't divide both by the same number and get 7/8, then the answer would be no, it's not a proportion. But 49 over 56 simplifies to 7/8. So, yes, it is a proportion. Alright, another way to determine if two ratios form a proportion is to use means extremes, also known as cross multiplication or cross product. Your book calls it cross product. Product is the result of multiplication. So cross multiplication or cross product. You use cross products to determine whether each pair of ratios can form a proportion. So here we have 0.25 to 0.6. And we're going to check to see if this is a proportion with 1.25 to 2. So we can check that by doing cross multiplication, cross product. Let me highlight this with a different color. So you'll multiply 0.25 times 2 and 0.6 times 1.25. And when we cross multiply 2 times 0.25 and 0.6 times 1.25. It's a good idea to use parentheses. I'll go ahead and put a parentheses around the 2 so it doesn't feel left out. This gives us 0.50 or 0.5, and this will give us, let's do that math, 0.730, 0.73. Uh-oh, those two things are not equal. If they are not equal, then our original problem was not a proportion. So was it a proportion? The answer would be no. Alright, let's check the next one. 4 to 5, does that equal 16 to 20? I already know that 4 will go into both of those, but let's check it with cross product. So we multiply, and we end up with 4 times 20 is 80, and 5 times 16 is 80, and 80 equals 80. So I said 4 times 20, does that equal 5 times 16? And we do get it, so yes, it is a proportion. In a proportion, we have two sets of numbers. The middle numbers are called the means. I'm going to translate that, the middle numbers. And then the outside numbers, the outer numbers, are called the extremes. And that leads us into the next page, means extremes. Let me show you here if I wrote A is to B as C is to D. My middle terms, when you think about cross multiplying, B and C are in the middle. B and C here are an example of the means, and A and D are an example of the extremes. They're on the outside. It's the first number you come to and the last number you come to, whereas B and C, this is the second and third, so they're in the middle. They're the means, and the outside numbers are your extremes. Okay, so this leads into means extremes, property of proportion. In words, the words, let's think about it in words. In a proportion, the product of the extremes is equal to the product of the means. That's what happens when we do cross multiplication. So let's review what I already wrote. A is to B as C is to D. Then A times D, that's your extremes, equals B times C. We could have said the means first. B times C equals A times D. They are saying the same thing as long as you've multiplied the means together and the extremes together. Again, A and D are the extremes. B and C are the means. So this is another word, or this is the formal way of talking about cross multiplication, also known as cross product. Your book's going to say cross product. All right, solve this proportion. I am going to use means extremes proportion to property of proportion to solve this. I'm going to rewrite it as a neater fraction. N over 12 equals 3 over 8. So I will multiply 3 times 12. That should equal 8 times n. So 36 equals 8n. Divide by 8, and we find out that the solution to this proportion, what makes this a proportion, n equals 36 over 8. Now let's simplify that. 8 goes into 36 4 times, and that'll leave us with 4/8 left over, so it's 4 1/2. So 4 1/2, and you are welcome to leave that as 9/2, because 4 goes 9 and 4 goes 2. 9/2 or 4 1/2, either one of those are a perfectly good answer for n. That's what's going to make, now that's ugly, that's a fraction within a fraction, but to make this a proportion, there is not a whole number that will make 3/8 with 12. It has to be 9/2 to make it equal to 3/8. Let's check that. Let me show you what that looks like. 9/2 divided by 12. They're telling us that this, or if I've done my math right, this equals 3/8. Well, we have a fraction divided by 12. Is 12 a fraction? Sure it is. 12 is understood over 1. So 9 over 2 times 12 over, or excuse me, I need to flip and multiply. I about made the careless mistake we all tend to make. 1 over 12, and that gives us 9 over 24, and 3 will go 3 times, and 3 goes 8. So it sure enough reduces down to 3/8. So 9/12 does make that a proportion, so this would be our final answer. I just wanted to show you that it does work. All right. The ratio of two measurements is called a rate. If we're checking two different measurements, comparing measurements, we're talking about a rate. They work very similarly to a proportion. Let me show you a situation where we have a rate. The gear on a bicycle is 8 to 5. That means that for every 8 turns of the pedal, the wheel turns 5 times. Suppose the bicycle wheel turns 2,435 times during a trip. So that's the wheel turning. How many times would you have to crank the pedals in order to make that happen? So during that trip, how many times do they crank the pedals? Now here, this one was a little tricky, I will admit. Let me read it again. The gear on a bicycle is 8 to 5. That means for every 8 turns of the pedal, the wheel turns 5 times. So they're both turning, but this one is pedals turning and this one is wheels. So what we are really comparing is the turn of the pedal to the turn of the wheel. So let me show you what I took from this. It's 8 to 5 for your bicycle, and then they told us we turned the wheel 2,435. So for wheel, I'm going to plug in 2,435, and the question is, how many times did I have to turn the pedal? So that's what I'm looking for. So I will use cross product. I always like to highlight that and show you how I'm cross multiplying here. And it'll be 5 times P equals 8 times 2,435. And that's 5P equals, that gives us 19,480. And then I need to divide by 5. And P is going to equal 3,896. That is how many turns the pedal will need to turn in order to make 2,435 turns of the wheel. All right. Should the pedal turn more than the wheel? Yes, because according to our ratio we were given, it's 8 to 5. So the pedal, because it's pedal to wheels, pedal turns more than the wheel. So that makes me feel like my answer is correct. Feel free to plug it in and check to see that it reduces to 8/5. Sometimes a ratio or a rate is used to make something smaller or larger. You're comparing the two. This is called a scale. You'll see scales used often in maps, blueprints. I'm sure there's other situations that I haven't thought to list here, but there's many times that we'll use a proportion to, to actually draw a house on paper. It would take way too much paper, but we can draw it to scale on a smaller piece of paper. Likewise, they do the same thing with maps. So I am going to leave example 5 here for you to attempt. If you, all I ask is that you try. That's the best angle to approach any problem, is the triangle. So please, you will need to set up a proportion to work this problem. I'll check this tomorrow. We'll go over it. Y'all have a super great day.